Today we are going to speak how we can start a maintenance system at any time. If you don't find the maintenance system that you are having in hand is good for you, or if you don't have what you call a system, just you are doing some maintenance activities and you think that I need some maintenance system. So why we need a system? The system simply, it automatically gives you some recommendations, what to do, what to not do, give you some indications and so on. We are going to see today the elements of a system so you can start a system directly after hearing this lecture, or directly in your workplace, directly anywhere you can start a maintenance system. It's easy, just it's a few steps that you need to follow, and then it will upgrade and automate, and it will go to the next level automatically. Just you need to know the concepts or the elements that you need to have in the system so you can get results. You need a system to get some results. Okay, we will go to this figure while we go down, because that's one of the very important parts about the timeline, because you compare maintenance against timeline, which is time is the most precious thing in life. Your time, the equipment time or the production time, time is the most, because you cannot retrieve back the time. If time passes, so you cannot get it back. So simply to start now with any system, you need to have some activities in the system, something you are doing in the system, some actions. So start by recording what you are doing now. You are doing some activities, even if it is repair an equipment when it fails, but just call it with a correct name. Call it as a corrective maintenance. So it is named as corrective maintenance. So if you, that's not bad behavior or something, because if you are doing even the reliability, which is one of the highest top or the highest or the top levels of analysis for the maintenance, you're doing some RCM analysis and so on, you will reach some activities or some equipment that against this failure there will be no scheduled maintenance. You will let it fail and then you will repair it. So you will do intended repair it when it fails. So don't be afraid, just write it as a corrective maintenance and start to record whatever you are doing and give it its correct names. The correct naming will enable you to update your system or upgrade your system or move in the right track. So if you are doing some activities based on a time stamp, so every week we do this, every month we do this, this number of operations, so you need to call it, it's time based, it's operations based, and so on. So the first step is to record whatever you do. So you have a set of activities that you are doing. When you have this set of activities, after that you record some data for this set of activities. Why you record data? In the previous few lectures we were speaking about the use of the data and the importance of the data and the data analysis. So simply you can start with your second step after you had the activities inside. For each activity you record some data. Why you record some data? So you can analyze them in the third step. So examples of the data that you need to record, for example, is the time taken to repair the equipment, the manpower needed, manpower cost in total, parts cost, effects on the production, and any safety issues that happen due to the failure, maybe oil leakage or dust or waste or something like that, or some burns, some flames came out, something, whatever, it depends on the industry or whatever you are doing. The third step is to review the data. That's a big chunk of our speaking today. What do we mean by reviewing the data? If you understand what you want to review in the data, you will be keen about recording the data. Sometimes when you need to have a look at the data recorded after some failures, because of course you cannot record one or two times and then you come to a conclusion. You need to record the data for some time. After recording the data for some time, for example, you will find that the repair time for the same failure ranges between 10 minutes and 55 minutes. So this needs to raise some questions inside you. These questions will allow you to refine your data or make some corrections that while building the system, you are correcting the maintenance that you are doing. So sometimes hiding these flows or fluctuations within a big set of data will not help you, because unless it changes a trend or an index or something like that, these big variations. But focusing on the data and the variations in the data will give you some indications that will help you in building your system. And of course, you can use some statistical or numerical analysis for your data just to get the idea that you need. For example, you get the mean, you get the deviation, which is the variation of the data from the mean, how the variation of the data, the minimum and the maximum, and so on. And then you can trend them with the raw data you are having. Like this, you can visually detect if something is wrong. So what can be wrong with the data? To know what is wrong with the data, you need to ask yourself some questions, like the 5 whys, for example, to adopt the methodology of the 5 whys. The 5 whys, you ask yourself 5 times why. That's to dig deeper in the root cause of this problem, or what can cause this change in data or variation or data, what can cause this failure, and so on. This will help you in creating better performing indications that, or indicators that we are going to see at the end of our talk today. So some variations come from that we record the error as the same failure, but actually it's coming from something different. So it was sensor, then a leak, and then something else, but it is recorded all as the pump or the motor or whatever. So also, for example, when we are going to when the team went to repair, the production team had added some covers for protection against heat or for safety, and then to repair the failure I need to dismantle the covers, so the time extended. Someone adjusted a sensor different from the original settings because to avoid its continuous failure, and then the seal was damaged. One technician was moved to another team or was on vacation, and then the time of the repairing of the failure extended. This means that there is no flow of information within the team. If you remember when we were talking about the blood flowing in the maintenance system, which is the data should be available to everyone. So this means that not all the team has the same available data or not have the same skills that you need to normalize this. Another thing which is very important, avoid the biasing of the first impression of the data. For example, of those biases, for example, it took 3 days to repair the equipment. Yes, but it's a standby equipment and the operation is continuing. So taking 3 days to repair an equipment may not be a big problem because you're having other priority activities to do. It costs about $1,000. Okay, but the equipment is $10 million in cost. There is no spares in the store, and we need to wait till we purchase some parts from outside. Yes, but that's the company policy, that not to keep any part of spares in stores. So you need to change the policy not to claim the trouble or the team or something like that. Our repair needs some specialized team which is coming from the manufacturer, and this took 48 hours and the production stopped. Yes, but I cannot guarantee the operation without the guarantee of the manufacturer, because that's contractually the manufacturer only should repair this big transformer, this CNC machine, and so on. So avoid the first bias of the impressions of the data. So also, you need to take care something sounding. For example, we lost the monthly plan due to the stoppages. Some slippage happened and caused some sprained. One of the technicians sprained his ankle. This failure is repeating 5 times a day. These all are flickers from the raw data you are having before analyzing them, or while analyzing them, while recording them, before putting them into indices or indices or indicators. Because putting them indicators will give you a direction or indication. So if you missed the analysis of the raw data, the indicators after accumulation of the errors or the failures and so on will give you some and some flags or red flags that take care that you are doing something wrong. But just we need to analyze the raw data or have a good look to the raw data, because rubbish in is equal to rubbish out. So if we entered rubbish in to the indices, we will have rubbish out indications from the indices, and we will not be able to make proper analysis and take take decisions, informative decisions based on the data we had collected. Okay, the probable source, there's another probable source of data variations is the variation between my team. So if I'm having a morning team, repair team, shift team, and so on, and the time differs between these teams, this means that my skills is not distributed among the teams, and then I need to make some internal training or data flow and so on. So after we had created we had known the analysis, how to analyze the data, how to record what data to record, and what to notice about the data that we recorded for any variations or deviations or something like that. Then we need to create some indicators that will point to me what are the main problems that I'm having if I don't get it from the raw data itself. But before going to creating the indicators, we need to know or to agree on one important thing, which is the timeline. Among all the people working in the organization in the same place, different departments, different departments and different business units and so on, we need to agree on dividing the time between time for operation, between ideal time, between downtime and so on. All these names need to have a solid written agreed upon timing, how to calculate each of them. So when we are comparing and when we are making our analysis, it is solid and clear for everyone in the working place. Because something, for example, the power outage from the government, from the municipality, or however you are taking your source of energy, electrical energy source. this can be classified as an idle time. It can be classified as an unscheduled downtime. It can be subtracted from the total available time, whatever. It needs just only to be agreed, like the raw materials shortage, like we are doing an upgrade for an equipment, utilizing the maintenance team. So this time of stoppage, how it is calculated and recorded in the monthly or the weekly, or however you make your records for the failures and so on. Because as I told you, the most important thing is the time. So you record mostly everything against the time. So you consume cost within a time. You consume man hours. You stop the equipment or the production within a time. So the time is the most important factor while you are working in the maintenance. So that's a simple analysis. You can agree with it, you can change it, you can just the total available time. It's available to the time available to produce and the total downtime. The time available to produce, it's divided between two. It's an uptime where the operation machines are working and producing, and an ideal time where there is no scheduling for the machines, but there is no other activities done on the machines. There is a total downtime, which is the scheduled downtime and the unscheduled downtime. So why it is called downtime, even if it is scheduled? Because during this scheduled downtime, the equipment is not available for production. So that's why we call it downtime. You can call it scheduled maintenance, you can call it whatever as you agree upon within your team or within platform, or whatever is better for you during your operation. But just you need to agree on how the time is divided, because you are going to compare every record with this timeline you are adjusting. So also, another important time for the calculation, you are calculating based, you need to normalize all the indices. It's either 24/7, if you are working 7 days, you are making calculations per week, or 24 times 30 if you are making your calculations on a monthly basis. Also, you need to agree if you are working 12 hours, 24 hours, the maintenance is done in the night shift where there's no operations. The maintenance is done during the weekend where there's no operation required. So it will have different calculations or different bases for the calculations. Okay, so all this need to be considered and settled first. Then you start creating your indices. The first thing you can calculate as an index is unscheduled downtime, which is the downtime or the equipment become unavailable for production during a time which is not indicated or not recorded in the weekly schedule of the operations, or the daily schedule, or the monthly schedule, however you record your schedule. So when this time is not recorded in the plan or in the schedule, then this time for maintenance is unscheduled downtime. As I told you, it's debatable that I can say that there's no production planned in this time, then I can do this time. But it's like this, you will lose your focus. You need to know what time actually you spend on maintenance, what is in the schedule. If it's not in the schedule, you need to know why it is not in the schedule. Okay, so the unscheduled downtime. So the unscheduled downtime, as I told you, for all the maintenance activities that is not planned to do. So, and then you can make it as a percentage. You need to compare to the base, maybe all the available time, all the timeline, or the whole total time, or total available time, or you compare it to total downtime. Just it's a comparison, and you select the base that will better represent you, or with an index for your performance. The maintenance cost, you need to make sure that you get a proper maintenance cost from your accountant, or you collect also only the hours and the parts, and then you wait a feedback from them. But just you need to make sure that you get proper values that is accepted. When you say my maintenance cost is X or Y, you need to have a feedback from the finance or the calculations, the true calculations they make. Also the mean downtime, which is an average. So if you have for example 10 hours for stoppage and 10 stoppages, so you'll have mean downtime as 1 hour. Mean time between failures, so the total time of operation of the machine divided by the number of failures. I hope this lecture is not long, but it's having very helpful insights for building your maintenance system. You can start your maintenance system at any time, just if you know the elements of the system. You record the activities, you record the data, you review the data, and you create some indices for you. If you feel that you need any help or support with this, you can join us on Fiverr. You will find the link after in the description of the video, or you can just drop us a direct request on the website. You will find our email also after the video, and you can see all these links also in the description, and you can see them also in the post. We will leave you the link for this post if you can spend some time reading it. I hope you had enjoyed this chat, and I hope you came up with some insights. See you in the coming videos with more insights from maintenance and to jumpstart our maintenance practices. Thank you very much.